In this lab, we will continue the step 2 of exploratory data analysis. This is to make ourselves familiar with the data set. So in task 2, let's also plot a histogram of each of the variable to see the distributions. So from plotly.offline, we have already imported iplot in the first task over here, so we don't have to do that again. So let's remove this. Code to create interactive histogram. Let fig equal make underscore subplots of rows equal 10, comma cols equal 1. So rows equal 10 because there are 10 variables. Let I equal 1. For col names in df.columns, so for each of the columns, if I mod 11 not equal 0, then fig dot add underscore trace bracket go dot histogram bracket x equal df of call names, so the columns, comma name equal call names, so the column names, comma close the bracket, comma row equal I. So for the first when I equal 1, then row equal 1 and column equal 1. Fig dot update underscore x-axis bracket title underscore text. So we will update the x-axis with the title, and that will be call names, comma row equal I. So the first one will be row equal 1, comma call equal 1. Set x-axis title for each subplot, and then increment I, so I equal I plus 1. Then when I is equal to 2, the for call names equal the next column, fig dot add trace bracket go dot histogram bracket x equal the column, comma and name equal call names, so the column name, close the bracket, comma row equal, so for I equal 2, row equal 2, comma call equal 1. Fig dot update underscore x-axis bracket title underscore text equal call names, comma row equal I, comma call equal 1. Set axis title for his subplot, and then increment I by 1. So when I is 11, then that will stop because I mod 11 mod 11 equals 0. Then fig dot update underscore layout of height equal 1600, so height of each of the histogram is 1600, comma width of the each of the histogram is 1300, comma title underscore text equal interactive histogram of each variable to see the distributions. iplot of fig, comma file name equal text dot html. So this will save the fig has file name task2.html. Interactive histogram of each variable to see the distributions. So we see for longitude and for latitude and housing, median age. So when you scroll over the plotted histogram, that gives us the values. And total rooms, it seems to be right skewed. Total bedrooms is right skewed, and population is right skewed, and households is right skewed. Median income is also right skewed, and median house value is right skewed, but then at 500,000 there is many houses with the value 500,000. Then we have ocean proximity. Less than 1H ocean seems to be having had the highest number of houses. Highest number of housing median age is 52. So we see that let's look at housing median age. So we can see that the highest is here 52. Households population. So households is where so we have population here and households here and total bedrooms. So we have total bedrooms, this one, and total rooms, which is this one, the purple one, and all these distributions are right skewed. Majority of population in total rooms is less than 5,000. Let's have a look. Majority of the population, yes, it's less than 5,000, and the total rooms is less than 5,000. Majority of households in total bedrooms is less than 1,000. Households, majority is less than 1,000, and total households total bedrooms is less than 1,000. This one. Median income is showing right skewed distribution, which is this one, and with higher number of people having median income between 1.5 and 6.5. So 1.5 is around here and 6.5 is around here. The number of median house value of 500,000 to 505,000 are much higher compared to the rest of the median house value. Let's have a look. This is median house value, and this bar here is ranging from 500,000 to 505,000, and there are 992 houses, which is the highest. The highest number of house locations are in less than 1H ocean. So as we can see in the ocean proximity histogram, less than 1H ocean gives the highest number of households. In task 1, we found that there are 5 houses located in the island category. Let's have a look. So the island category is down here, and there are 5 houses located in there. The plots are submitted as separate HTML file called task2.html. That's why in the code we have iplot bracket fig comma file name equal task2.html. To visualize density plot of categorical variable ocean proximity, we need to encode it first. Let's apply label encoder. From sklen.preprocessing, we import label encoder. Use label encoder function to encode column ocean proximity. So let's make a copy of the original data frame. Let temp equal df.copy open and close bracket, and let's look at the first few lines of this temp data frame. Temp the ocean proximity equal label encoder open and close bracket dot fit underscore transform of the column ocean proximity. Let's look at the first few lines of this temp data frame. Temp dot head open and close bracket, and we get this, and we can see that in the ocean proximity column the categories nearby has been changed to value 3. And then let temp1 equal pandas dot data frame bracket square bracket the ocean proximity column dot value underscore counts open and close bracket dot index. This will give us these categories: less than 1H ocean, inland, near ocean, nearby island, and the next one is temp and then bracket ocean proximity. So the ocean proximity column from the temp data frame dot value underscore counts open and close bracket dot index, and that will be for less than 1H ocean we have 0, inland we have 1, near ocean we have 4, nearby is replaced by 3, and island is replaced by 2, comma empty space, and close that close the brackets, and then dot T. So temp1 dot head that will give us temp1 dot head. So let's do temp1. So temp1 gives us these values here. Do we need to have this space? No, we don't need. And do we need this dot T? So by putting T we get in the column form, and when we don't put T then we get in the row form. So dot T, the vertical form looks better. Rename the columns. Temp1 dot columns equal square bracket factors comma encoders. So we have factors and then the encoded value. So printing temp1 gives us these values here. So less than 1H ocean is 0, inland is encoded as 1, near ocean is encoded as 4, nearby is encoded as 3, and island is encoded as 2. From the above table of value counts, we see that less than 1H ocean is encoded as 0, inland is encoded as 1, near ocean is encoded as 4, nearby is encoded as 3, island is encoded as 2. Let's visualize. So we won't visualize the density because it is very close to the histogram. So either we visualize the histogram or we visualize the probability density distribution.